All right, here it is. We are at the very last video. This is part 6 of the ACT 2020 practice test. So again, just to reiterate, this is, if you go to the link at the bottom here, which I've included in the description below this video, this is the preparing for the ACT test number 1, right, 2020-2021. It is form 1874 FPRE, right, so you can verify that you're on the right form. We are starting this particular video at question number 51. So if you are finding this video for the first time, this is part of a playlist. This is the 6th of 6 videos. So if you go to the playlist, which is also linked in the description below, you can start off at problem number 1 or wherever you choose, right? Each video is just 10 problems to try to break it up a little bit for you, okay? So we're going to jump right into it. Right, here is problem number 51. Okay, so this is the list of numbers 41, 35, 30, x, y, and 15 has a median of 25. The mode of the list is 15. To the nearest whole number, what is the mean of the list? Okay, so here's the idea with this one. So let's start off with mode. Okay, mode is the most repeated number on the list. So what we know is, since there are no repeats on this current list, that 15 has to be at least one of x and y. So if I'm kind of going through the list, I'm going to write them in order from smallest to biggest. My smallest number is 15. I know there has to be at least one more 15 on my list. Okay, that's the only way that it will be the mode. Okay, and then I know I have the numbers 30, and then 35, and then 41. Okay, so I don't know where this other one. So let's say we used up y, right? We don't know what the extra value is. That's where the median is going to come in, right? So I currently have a list of 1, 2, 3, 4, 5 numbers. Median is defined as the middle number of the list, okay, when it's in order from smallest to largest. So right now I have the 5 numbers that I'm sure about, but there is a 6th one, and I don't know where it is, okay? So let's say, for example, I put it at the end, right? And so this is where x is located. If I were to find the middle of the list, here's where I'd go. I'd say, okay, 15 and x are the first and last, then 15 and 41, which means these two numbers share the middle. And if I add those up and divide by 2, okay, I'm going to get 32.5. 32.5 would be the median of this list, okay? So what I need to do is strategically place x in such a way that I will get a 25, right? So I'm going to place it somewhere around where 25 would be, right? And so instead of placing it at the end, I'm going to choose to place it right here between 15 and 30. That's where 25 would be located. So I'm going to place it right here instead, okay? So now, if I were to say what is the middle of this list, okay, my answer would be that if I chop off the 15 and the 41, the 15 and the 35, x and 30, okay, are the two shared middle values. So if I add those up and divide by 2, that's going to give me the median, which is 25. And so that means if you do a little bit of algebra, okay, you find out that x has to be equal to 20, right? So I know that this x value, instead of me putting an x there, let's get rid of that, and in its place, I'm going to say this has to be a 20, right? So we figured out what these missing values were. One of them has to be a 15 in order to get a mode of 15. The other one has to be 20 in order to get a median of 25. Their question then is, what is the mean of the list, right? So mean, let me pull up my calculator, okay, is going to be add up all these numbers and divide by, in this case, 6, because there are 6 numbers, right? So here's my calculator. Okay, and so I'm going to just go to my home screen, clear everything out, and I'm going to add these up. 15 plus another 15 plus 20 plus 30 plus 35 plus 41. My sum is 156. I'm going to divide by 6, okay, and it's going to give me a mean value of choice letter C, which is 26. Okay, so we're going to go back to our problem and say the answer is choice letter C, okay? All right, problem number 52. Okay, this one is going to be a formula sheet problem, but we'll talk about that in a second. So you're given the following system of equations. Their question is which one of these is true, right, for for this given system. Okay, so here's the idea with this. Whenever there's a system, usually you're going to either do a substitution or an elimination. This is a great substitution problem because they're telling you what y equals. So off to the side, my first strategy whenever I see a system is to try to substitute. So I'm going to take this y out. I'm going to say rx plus s. And instead of writing y, they're telling me I'm allowed to substitute x squared. So I'm going to do that. Okay. And now I'm looking at this, and it kind of looks like a quadratic. So I'm going to just rewrite this a little bit. I'm going to put the x squared first. Then I'm going to put the x to the first power. And I'm going to decide to set this equal to 0 by moving the t over to the other side, right? So this equation here kind of represents the combined, if I took this information, plugged it in, and then just kind of messed around with the order of it, okay? And so they're giving us this expression. So here's where we're going to bring in the formula sheet now, okay? It says, for which of the following will there be more than one solution? Okay, so if I go to the formula sheet, I'm going to pull it up for you with my PDFs. Here it is, okay? So on the formula sheet, let's zoom in a little bit, okay? We'll go down to discriminant, which is right here, and zoom in, okay? There's this thing called the discriminant, which it tells you specifically for quadratics. If the discriminant is greater than 0, you will have 2 solutions. If the discriminant is equal to 0, you will have 1. If it's less than 0, you will have none. Okay, so they're telling us right above this that the discriminant is b squared minus 4ac. Excuse me. So if I go pull this information back to my problem, okay, I'm going to say, okay, I'm going to calculate the discriminant, b squared minus 4ac. And I would like that to be greater than 0. And I want it to be greater than 0 because that was the one that gave me more than one solution, which is, in this case, exactly 2. Okay, so if I plug in these 3 values, right, this is kind of my a value, my b value, and my c value. Okay, if I plug these into the discriminant, here's what I'm left with. R squared minus 4, instead of a, our problem has an s. Okay, and then instead of c, our problem has a negative t. Okay, and that has to be greater than 0. Okay, well, this negative and this negative can be multiplied together, and instead I'm going to write this as plus 4st. That has to be greater than 0. That's going to be our choice letter F. Okay, so this was a formula sheet problem. If you don't remember things about the discriminant, it does have that on there for you. Okay, all right, problem number 53. The third and fourth terms of an arithmetic sequence are 13 and 18 respectively. What is the 50th term of the sequence? Okay, so here let's start off with the vocabulary. Arithmetic sequence is a sequence where the numbers increase by addition or subtraction, right? So I'm going to say that if I have terms of 13 and 18 as the third and the fourth term, the way that I'm getting from 13 to 18 is to do a plus 5. Okay, so what I want to do is get back to what is the first term of the sequence. So the second, it looks like, is going to be minus 5 from 13. That's an 8. Minus 5 from 8, that is a 3, right? So these are the first 4 terms of my sequence now. Okay, and I really care about this one. What's the first term? Okay, so guess what? This is another formula sheet problem. Let's bring up our formula sheet. Okay, and I'm going to scroll, okay, until I find arithmetic sequence on here. So really getting comfortable with where everything is on here. I don't really know where it is, so I'm wasting time, right? I don't see it. Oh, here it is right at the top, okay? So arithmetic sequence with a constant of c, excuse me, says that if you want to find a specific value in the sequence, you're going to start off with a1. a1 is the first value in the list, plus c, which is how much we're increasing, times n minus 1, which is whatever number you want to know about, minus 1. Okay, so let's go take I'm going to write this down. So I'm going to say a to the n, okay, is equal to, I'm bringing it back to my problem, the first value of the sequence plus c times n minus 1. Right, this is how I do arithmetic sequences. Okay, so I'm going to go back to my problem, okay, by getting rid of my formula sheet. Okay, and we're going to plug in a1, right, the first term of the sequence is 3. Our constant is increasing by 5. That's how this sequence is existing. So I'm going to call this 5. And then if we want to know the 50th term of the sequence, 50, that's going to be the n value. So I'm going to say 50 minus 1. Okay. So my a sub 50, which is going to be the 50th term of the sequence, is going to be going to the calculator, okay, and typing this in. It's going to be 3 plus 5 times 50 minus 1, which I'm just going to type in as 49. And that's giving me a 248, okay? And I can see that 248 is the very first number on my multiple choice. That is the 50th member of the list, okay? So again, knowing that arithmetic sequence is something that you can use the formula sheet for is important for you to be able to do this problem without memorizing, okay? All right, problem 54. One of the following graphs in the standard xy coordinate plane is the graph of y equals sine squared plus cosine squared over some domain, okay? So couple of strategies here for this one. So this is starting to get into like pre-calc stuff, trigonometry. So the first thing is to use your calculator if you have a graphing calculator. So let me bring that back up real quick, okay? And then I'll show you how you really actually don't need to use the calculator for this one. But if you don't remember, this is a good strategy, okay? So I'm going to go to my y equals button in the top right, and I'm going to type in the equation that they just gave me, okay? So the equation is sine squared x plus cosine squared x. So the way that we type that in the calculator is just type in the sine of x, close it, and then hit the squared button, right? Sine squared of x is the same as sine x squared. They mean the same thing, okay? Plus cosine squared, right? So I'm going to hit my cosine button and then do x squared, okay? And I'm going to hit the graph on this. So let me just kind of, I'm not going to hit graph button, but I'm going to show you what your problem probably looks like is something like this, okay? And it's just a straight line. And you might be thinking, hey, I must have done something wrong, right? What you want to check, and it's actually not going to do anything for this problem, is you're going to hit the zoom button. And because this has trigonometry, if you notice that there is choice number 7, Z trig, right? If I hit the number 7, it's going to change the window. But I'm still getting the same thing. I'm getting this line that goes across 1, okay? So let's go back to our problem real quick, okay? And just take a look at the answer choices. If you notice, choice letter H is the only one that is a horizontal line that looks like it's up at 1. That's actually your answer. Okay, so that's all you really have to do for this one is kind of compare the graphs and say, okay, there it is. Okay, choice letter H. Okay, here's another thing you could have done. If you don't have a graphing calculator, I'm going to bring up the formula sheet. Okay, so on the formula sheet, there's also some information about this. Okay, so let's bring up the formula sheet. Okay. Just get the whole thing on there, okay? And we're going to scroll down, and if you notice, let's find it. Again, knowing this stuff beforehand is going to be helpful. Right here, right, they're telling us that sine squared x plus cosine squared x is a trig identity that is equal to 1. So really, what this problem is saying is, what is the graph of y equals 1? Well, that's just a horizontal line. That's what choice H is saying, right? So it does make sense what our graph did. If I got rid of all of this and I replaced it with what it equals, this is just going to say y is equal to 1. And that's what that graph is. So any way you do it, it works out. So again, get comfortable with the formula sheet. You'll see that there's a lot of information on there that will help you out, okay? Problem number 55, okay? What is the period of the function f of x equals the cosecant of x? Okay, this is not on the formula sheet, so I'm pointing it out to you. If you want to find the period of one of these trig functions, you're going to use the formula 2 pi over the absolute value of b, where b is the number that's in front of the x. You do have to be careful, right? If, for example, this was cosecant of, like, I don't know, 2x plus 5 or something like that, you always want it to be written in the form 2x plus 5 halves, okay? In either case, it's the 2, but there is a standard form to how these look, okay? For this problem, though, all you're going to do is plug in 4, take its absolute value. It'll be 2 pi over the absolute value of 4, right? And that's going to be just 2 pi over 4, which is equal to pi over 2. So we'll say the period of this cosecant function is choice letter E, which is pi over 2. Okay. Problem number 56. At a school carnival, Mike's playing a game in which he's tossing 3 coins. At the same time, he will be awarded 3 points for each coin that lands heads facing up. Okay, so let's start off with that before we get to the question. For each of these coins, we don't care that it's a penny, a nickel, and a dime. They all have a probability for heads, okay, of being equal to 1/2, right? So probability is always the likely outcomes, which is in this case 1 heads out of the total possible outcomes. Well, it could be heads or tails, so it's a 1 out of 2 chance. Okay. The question here is, what is the total number of points awarded? What is the expected value to be of that, right? So let the random variable x represent the total number of points awarded. What is the expected value of that variable? Okay, so here's what expected value is. Okay, expected value is the probability that something's going to happen. So in this case, 1/2. Okay, so this is actually x, the random variable x. It's 1/2 times the number of trials, right? So in this case, we're only flipping the penny 1 time, right? So the expected value of getting a penny is going to be 1, okay? So we're going to say that, I'm sorry, is 1/2, I'm sorry, okay? And then we're going to say, okay, well, if that's the case, I'm going to actually get 3 points whenever that happens. So if I do times 3, right, that means that my total number of points for just the penny, the expected total points is 3/2, 1.5 points, okay? The same thing is going to be true of the nickel, so I'm going to have another 3/2 expected value for the nickel, and I'm going to have another 3/2 expected value for the dime, and that in total makes 9/2, right? So the expected value for one coin, right, is going to be 3/2 because it's the number of trials, okay, the probability, which is 1/2, times the number of trials, 1, and that's going to give you the expected value, right? But then because each of these flips is worth 3 points and not just 1, it's going to be 3/2, right? So our total answer here is 9/2, right? So problem 57. For what positive real value of k, if any, is the determinant of the matrix with this thing equal to k, okay? So note the determinant is this thing equals AD minus BC, okay? So this is a little bit of linear algebra, okay? But you don't need to really know anything about linear algebra except what they just told you right here, okay? So here's what this problem's saying. If you want to calculate the determinant, it says when is the determinant equal to k, okay? And if I want to find the determinant, what I'm going to do is multiply together a times d, which are these two values, okay? And a minus b times c, which are these two values. Well, in our problem, a and d is k times k. That's k squared. So let me actually write this right underneath the determinant formula, okay? So I'm going to say, if this is k and this is k, well, that's going to be k squared minus, okay, my b and my c values are 4 and 3, so I'm going to say this is 4 times 3, and that's going to be equal to 12, okay? So they want the determinant to be equal to k. Well, here's my determinant. They should be equal to k, okay? And they want us to solve and figure out what positive real values of k will make this equation true. This is a quadratic equation. I'm going to subtract this k over and say k squared minus k minus 12 is equal to 0, right? Get it in factorable form, okay? And then once I've done that, I can now factor this by saying that this is k minus 4 and k plus 3 equals 0. And I'll get two answers. One answer is k is equal to 4. The other answer is k is equal to negative 3. However, it says for what positive real values of k, right? So I don't want the negative value of k. I'm going to take 4. My answer is B, okay? This is really a factoring and solving problem, but they're throwing a little bit of other kind of expand your brain math at you, okay? All right, a couple more to go. 58. Given the positive integer n such that I to the n equals 1, which of the following statements about n must be true? So this is something called the cycle of I, okay? And this is using imaginary numbers where I is not just a variable. It actually means I squared is always negative 1, okay? So here's what they're saying about this. We have this thing called the cycle of I. Okay, so I'm going to write it out for you. You should have seen this probably in Algebra 2 or potentially pre-calculus or both, okay? And here's what the list says, okay? I to the first is just regular old I, okay? That's what I to the first is, anything to the first power, okay? I squared, they're actually telling you over here, that's negative 1. I to the third is negative I. I to the fourth is going to be positive 1. Okay? What the cycle of I does is that when we go to I to the fifth, okay, it's going to jump back to the top of this list. I to the fifth is also equal to I to the sixth is also equal to negative 1. I to the seventh is also equal to negative I. And I to the eighth is also equal to 1. Okay? So here's what I want you to notice. Okay? 4 and 8 are both nice multiples of 4, and they give me a 1. And that is not true of any other multiples for the exponent. Right? If I check multiples of 3, I can see that I to the third is negative I, but I to the sixth is not also negative I. It's something else, right? So multiples of 3 do not equal the same thing. Multiples of 2 do not equal the same thing. But because this is a 4-item list, multiples of 4 will always be the same thing, okay? So what they're saying is when n is divided by 4, the remainder is 0. That is a fancy way of saying multiples of 4, right? So in this case, what we care about is when n is divided by 4, okay, the remainder is 0. That is when we're going to get a 1 as our value, okay? So that's the answer for 58. Okay, 59, okay, it says for negative pi over 2, for all the values between negative pi over 2 and pi over 2, the absolute value of sine theta is greater than or equal to 1 is true for which of the following sets. Okay, so just to kind of talk about notation real quick, when I write it like this, okay, all I'm saying is literally just one value, two values, and that's it. Okay, letter B is just saying just pi over 2. That's the only one value that works. And then once I get down to C or D, we're saying everything that starts at negative 2 and negative pi over 2 and ends at pi over 2, but not including them because I don't have the greater than or equal to, less than or equal to symbols. This is the same thing, but including those end values. The empty set means literally nothing works, right? I can't put anything in the list, okay? So we have 5 options here. 2 of them are kind of a whole range of values. 2 of them are just specific numbers, and the last one is actually saying nothing works, okay? So this is, again, a great calculator problem. Hey, if you haven't done a whole lot of trig prior to taking this test, so let me bring up my calculator one more time. Okay, I'm going to clear out my sine squared plus cosine squared theta, and instead I'm just going to put the sine of x in here, right? And again, go zoom and then hit choice number 7 for trig. And it gives me this graph, okay? If you want to get really fancy and put in the absolute value, I'll show you how to do that too. In the math menu, if you go over to the right once, there's an ABS at the top. That's how we do absolute value. Right? And if you notice, that brings in the absolute value, and then I can type in sine of x, okay? So however you want to do it, that's how we're going to work these. Okay? So let me get rid of all this extra stuff, okay? Sine of x, okay? Close that. Okay, there it is. And I have to get rid of this one at the end too, okay? So here's what the absolute value will look like, okay? Just that. Okay, so the reason I want to show you both is because if you notice, this is the exact same graph, but everything that was below the axis, below the x-axis, the negative part, just became positive, right? So let me go back to the regular one. This is just sine of x, right? So you can see it one more time, okay? All I did for the absolute value one is take all of these negative numbers, the negative parts of the graph, right, and make them positive, right? So the humps that are above the line are the ones that are below, just kind of flipped up, okay? But here's the thing. It actually doesn't matter. What they're asking is, when is this graph greater than or equal to 1, okay? So if I take a look at this graph, it is greater than, it's never greater than 1, right? The graph goes as high as 1, and then turns around and goes back down to negative 1, and then it turns back around and goes back up to 1, and then back down to negative 1, and it keeps doing that. So it is never greater than 1. However, there are some spots where it is equal to 1, okay? And so if I'm looking at this graph, each of these dashes represents pi over 2. So it's pi over 2, pi, and then 3 pi over 2, 2 pi, etc. So if I take a look at it just from negative pi over 2 to pi over 2, it's essentially from the first dash on the left of 0 to the first dash to the right of 0, and the only spots where that's going to be equal to 1 is exactly at those values, right? So if you notice that pi over 2, that first dash, goes exactly up to 1, and negative pi over 2 goes down to negative 1, but when I take its absolute value, it will bring it back up to 1. So if I go back to my choices, okay, by getting rid of my calculator, what we're going to claim is that only at the specific values, negative pi over 2 and pi over 2, does the graph reach negative 1 and 1. And then when I take its absolute value, they both become 1, right? It never gets greater than 1. So I would never be able to include any other values. Okay, for every other value, it is smaller than 1, so I can't include any of these range values. Okay, all right, last problem. Okay, it says ray PK bisects LPM. So let's start with that. Here is angle LPM. Okay, so you're just going to draw an angle. Okay, I'm going to put 3 points on the angle. Okay, if these are rays, I'm going to throw some arrows on the end. Okay, and I'm going to say LPM is going to be L. P is in the middle of this name, so I'm going to put P at the vertex, and then M is over here. Okay, and then they're claiming that PK bisects LPM. So out of point P, I'm going to draw a line. Bisect means to cut into 2 equal pieces. So here's ray PK. And what I know, I'm going to use some geometry notation, is that these 2 little sections, okay, are equal. The angles are equal. Okay, so they're saying that the measure of LPM, the big one, right? So I'll use the little kind of big curly brace out here to say this is 11x. And the measure of LPK, this little one, is 4x plus 18. And they want to know what is the measure of KPM, which is this other little one. So here's what I know. Because bisect means to cut into 2 equal pieces, this piece right here is also 4x plus 18. Okay, that's one thing. That is the kind of the angle bisector rule. Okay, the other things that you need to know about this is that if you add together these 2 small angles, it should equal the original big angle. So if I add together 4x and 4x, I get 8x. Okay, and if I add together 18 and 18, I get 36. Okay, and that should be equal to the entire big angle LPM, which is 11x. Okay, so if I solve this, I'm going to get a 36. I'm going to subtract this 8x to the right and get 3x. Divide by the 3 on both sides, and I'm going to get that x is equal to 3. Okay? I'm sorry, x is equal to 12. Let's fix that, okay, because I divided by 3. So here's the thing. It's very common on this test to get this problem wrong because you see a 12 and you're like, I really want to plug in that or circle that answer because I got a 12. Okay? They didn't ask me, though, what is the value of x. They asked me what is the measure of angle KPM, which means I need to take this 12, plug it in, and say, really, I got to do 4 times 12 plus 18. Well, that's 48 plus 18, and that looks like 66 degrees, right? So that is the answer that we want, not 12, right? Even though x was 12, our final answer is going to be 66 degrees, okay? So that's it. That is number 60. We've done all 60 problems in practice test number 1 on the official ACT Guide 2020. Okay, if this was helpful to you, I hope that you will subscribe to the channel. You will like any and all of these videos, and you will leave comments about any questions you have on any of the content that you saw. I'm happy to walk you through it in a little bit more detail via the comments. Okay, you can also share these videos if you find them useful with any of your friends or anyone else you know that's taking the ACTs. That would be helpful, very helpful. And hopefully, I will be making an SAT video. So if you plan on taking the SAT or know anyone that is also going to be taking those, there will be a video series coming out shortly, which will do SAT prep as well. Okay, so thank you for coming along for all 60 problems. If you haven't viewed some of the old ones, remember there is a playlist down in the description. Okay, and I hope this was helpful in you preparing for the ACT math test this year.